All right, here we go. New chapter. Isn't that exciting? It's always fun. Seemed like chapter 6 went by pretty quick, didn't it? It seemed like it did. All right, so we are going to talk about the area of stuff. All right. Start off with rectangles. That's the easy one. You probably knew that before you walked in the door first day of school in here. Did you? What's the area of a rectangle? Anybody know that? That's something you probably have memorized before today. Okay, base times height, or sometimes they use what? Length and width, correct. All right, we can use either one, but we are probably going to stick with base and height. So let's just talk about that. Now, we know all about rectangles. We know a ton of stuff about rectangles, all right? But now we're going to talk about rectangles in a different way, and parallelograms and triangles. So we've learned a bunch of stuff about rectangles, parallelograms, and triangles, but this is going to be different. We're finding the area. Basically, the area is how many squares can you fit inside of that object. That's basically, it's not like a formal definition, but as far as what we are trying to figure out, that's basically what it is. Okay, how many squares can you fit into this? So, I probably should have had something maybe prepared, but I'll tell you what, let's do this instead. We'll do that in a second. So, there's a square. All right, so I'm going to copy, and then I'm going to paste in place, and then move it right there. Give me a minute, okay, to do this. Copy and paste in place. All right, I'll do one more set of these. Copy and paste in place. All right, that's good enough. All right, now I'm going to do a couple rows of these. That's maybe 3 rows. How's that sound? And then do another one. All right, there we go. How's that? That's good enough. So what we're going to do is this makes a rectangle, doesn't it? All those boxes, they're squares. Okay, I made those squares. So a square, all 4 sides are equal to each other. A rectangle, all 4 sides are not necessarily equal to each other, are they? All right, so what am I asking for to find the area? I'm asking how many squares, okay, are inside that rectangle. So you could just sit there and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or you could do what? How many across did I say there was? 8. All right, so there's 8 of these across. And how many are up and down? 3. All right, so you could call these rows and columns if you wanted to, right? But how do we find how many squares there are? We could just count each individual one if we wanted to. But what if I had like 50 columns and like 27 rows? I wouldn't want to sit there and count every single one, would I? All right, so what do? We count how many we got across, how many we got up and down, right? And then what do we do with those 2 numbers? Just multiply them together. So how many squares are there in that rectangle? There's 24 of them, okay? That's basically how you find the area of a rectangle, all right? But we call this the base, even though it's on top, because what's the bottom? It's going to be the same thing, isn't it? That length on the bottom, it's going to be the exact same thing. So we call one of the sides the base, and we call the other side the what? The height. You could call it length and width, okay? A lot of times we grow up learning length times width. Were you ever told that earlier? Yeah, probably. But what we're going to do is we're going to stick with base times height because we're going to use it a little bit later, all right? Now, there's something important about the base and the height. The base and the height need to be perpendicular, okay? Are the base and heights perpendicular on this thing? Yeah, it's a rectangle, right? So that base and that height, yeah, and these are all squares, so they're all right angles. So sure enough, the base and the height are perpendicular to each other. But that's very important. It's a very important thing. The base and height must be perpendicular to each other. Everybody got that? You may want to jot it down. I didn't write it down, but you might. And we have 24 squares. Let's say this was in inches. That's 8 inches. So this is 1 inch by 1 inch. All right, so these squares are 1 inch by 1 inch. So what are we going to do? We're going to go 8 inches times 3 what? Oops, why did I write an 8? 3 inches. So 8 times 3 we've already done. We said it's 24. But let's do the units as well. It's very, very important that you do units when you do area. Okay, it's super important that you consider your units. So I've got inches times inches. How would I write inches times inches? What's anything times itself? Something you learn in regular math class. Anything times itself. 3 times itself. 5 times itself. 10 times itself. X times itself. It's squared. It is squared. That's right. So what's inches times itself? Inches squared. Exactly right. So inches squared. So with area, when you do area, your units are always going to be whatever your units are squared. Okay, if it was feet, it would be feet squared. If it was yards, it would be yards squared. If it was centimeters, it would be centimeters squared. Everybody with me on that? All right. So we can write it like that. Now, let's say you go to the store and you want to buy some carpet. I think they probably sell carpet, I don't know, either by the yard or the foot. I'm not really sure. Let's say by the foot. So if you go and you want to find out how much your piece of carpet is going to cost, right? So let's say it's 8 feet by, that little X right there, they'll say it's 8 by 3 or 3 by 8. You've heard that before, right? With pictures. You've heard 8 by 10, 5 by 7. Have you heard those numbers before? Yeah. All right, so that's the X by what? 3 what? Feet. So you could say it's 24 feet squared, but a lot of times you'll see this. You'll see square, SQ, and just a period, and then feet. Square feet or square inches or square yards. You ever hear that expression before? It's the same exact thing. But in math, we're not going to write the SQ period for square feet, okay? We're going to write it like this. We're going to write feet squared or inches squared, okay? Everybody with me on that? All right. So that's not too hard, is it? So how many squares are in that thing? There's 24 squares. If I wanted to count it up, boom, 8, that's 16, and another 8 is 24, okay? That's easy, isn't it? So we need a little formula then, because we're going to be learning some formulas in here, all right? So I would write these down. I'll probably put them in a box or circle them or something like that. So the first one is the area of a what? A rectangle. This is the first one, and it's probably the easiest one because it's one that you've seen so many times before. So the area of a rectangle. Now, since I called this the base and this the height, how am I going to write the area of a rectangle? Base times height. That's right. Base. You can just put the B and the H right next to each other. That means they're being multiplied. So there's your first formula. The area of a rectangle is the base times the height. What has to be true about the base and the height, though? They got to be perpendicular to each other. That's really important. On a rectangle, it's kind of a given, isn't it? Because you know in a rectangle it's already perpendicular. But what about a parallelogram? All right, the height has to be perpendicular to the base. A triangle, the height has to be perpendicular to the base. Well, we've done rectangle. Let's do square. It's really, I would almost recommend that you don't even memorize this formula, okay? I'm going to give it to you because they do it in the book, okay? But a lot of times they call this is a square, by the way, all right? And a lot of times they'll say this is a side and this is a side. Now, what's true about all 4 sides if it's a square? They're equal to each other, okay? So here's what they would do for the area of a square. To me, it's almost not a waste, but you don't really even need to memorize an extra formula for the area of a square because you already know the area of a rectangle. A square is a rectangle, isn't it? It just happens to be a rectangle with all 4 equal sides. So really, you could have called this the what? Instead of S for side, you could have called it what? B for base. And you could have called this one up and down, which is perpendicular to it, the what? The height. So I could have still said this is the area of a rectangle, just gone base times height. Would you agree? All right, but the book does this, so I'll do it. But I don't know, it's almost a waste. Almost. So the area of a square, let's not use base and height this time. What are we going to use? The sides. So since both the sides are exactly the same, it's what? Side times side. But what's anything times itself? It's the side squared. So if you wanted to remember that, okay, special, I guess you could. But you already know the area of a rectangle, so why even bother having another formula for area of a square? Wouldn't you agree? But sometimes people like that. They're like, oh, okay, it's just s squared. Everybody with me? Yeah, that's easy. Let's see, what else? Yeah, let's just skip down to the next thing. There's a couple things I had in my notes, but we've kind of talked about them already. So let's go to this. Let's go to a parallelogram. All right, and we're going to make this lean just a little bit so it kind of looks like what we're used to as a parallelogram. There it is. All right. So now we got to find what the area of a parallelogram is. I'll tell you what, let's not just put A, put area of a parallelogram. The nice thing about the area of a parallelogram, it's the same exact formula as the area of a rectangle. So really, we've learned 3 different figures, but the equation has been exactly the same for all 3 figures. That's kind of nice, isn't it? All right, A for area, right? So what did I say the area of a rectangle is? So that's exactly what it is with a parallelogram. Okay, so the area of a parallelogram is the base times the height. But now, this is where it's really important to understand the relationships between the base and the height. What did we say the base and the height were? Or what did I say the relationship was between the base and the height? They have to be what to each other? Perpendicular. Okay, we said that a whole bunch. Straight there. Yeah, right past. All right, everybody got that? But the problem is, if I call this one the base, can I call this side right here the height? Why not? Because it's not perpendicular. So where's the height then? It's just anywhere, really anywhere from this side right here. I'll just start at this vertex. And then where? Don't say straight down. Perpendicular, right. Okay, because everybody wants to say straight down. I get it, okay? It's not a terrible thing to say, is straight down, but it is perpendicular. Oops, let me get my pen here. There you go. All right. So what's that red one right there? If it's perpendicular, that would be the what? The height. Okay? So the base goes all the way from here to here. Everybody see that? Sometimes this is how we mark it. You understand that little notation right there? Just means B is from here to here. Right? That's the whole entire base. It's not just like from where that perpendicular hits. Okay? It's the whole entire bottom of this parallelogram. And the height would be this one right there. Okay? Or there's another place you could look at. Tell you what, let's just slide this down. You could look at it like this as well. I mean, the height could be really from anywhere up here perpendicular. As long as it goes perpendicular. You could start it here and go where? Perpendicular to there. Would you agree all 3 of those red lines right there are exactly the same? So all 3 of them could be considered the height. Okay, there's another height that you'll see every once in a while. And watch, I'm going to put a little dotted line right here. The dotted line just means I'm extending that out a little bit. And then I could go from here perpendicular to that extension. Even though it's not technically hitting the base of it, because remember, the base stops right here. Okay? This is if I extended it out a little bit, imaginary extension, and then that would still be the same height. So all these red lines right here are still the height. Agreed? So every once in a while, you'll see it like this. You'll see it extended out like this. This does not mean that's part of the base. Everybody understand that? I've just extended it out and dropped that perpendicular. So all these, if they're perpendicular, all these would be the height of the parallelogram. This one right here, but you're going to see that though, so I want to show it to you, because if you see it in the book, you're like, what? Why they put that dotted line there? I don't understand. Well, I just showed it to you, okay? Because there are times where they will give you that particular height and they'll extend this out a little bit. So I want you to understand what they're doing here. Let's do an example with this, and then, man, we're almost finished this. If I do this example, I got one little thing to do. Let's see if I can finish it. I don't know if I will or not. I got 4 minutes. So let's make it slant in the direction that the book does. Yeah, it's kind of like that. And this is an example, correct. This is example 2. And it asks you to find the area of this parallelogram. So they say that's A, B, C, and D. Now watch what they do here. They give you a line segment, about right there. It looks good. So what do you think that yellow line right there is going to be? It's going to be a height. Why do you think it's the height? Yeah, it goes from one side perpendicular to the other. Exactly right. Can somebody get that door? I think she's trying to get in. Was she? Did she? Okay. All right, so here's what they tell you. They tell you that AD is 25. They tell you that DC is 13. This is in inches, by the way, so let's put the units. And they tell you that yellow one is 10. All right. Now, they just do that just to trick you up a little bit. All right, so they want you to find the area of a parallelogram. What's the formula for area of a parallelogram? It's the base times the what? Times the height. But the base and the height have to be perpendicular to each other. So they give me 3 numbers. Which one did you say the height was? Probably the 10 inches, right, because it's perpendicular. So I'll call that one the height. But it goes to here, so what do you think the base is? BC, right? Yeah. But if AD is 25, what's the length of BC? That's also 25. Now remember, the 25 goes from here all the way to there. Everybody see that? From there to there, and that's in inches. So even though they gave you this as the base, these two would be considered the base. Now notice, the base, it doesn't always have to like sit on the base, all right? Everybody thinks that this one should always be the base. Okay, well this one really has nothing to do with our problem. We don't even need to know this at all. Okay, all I need to know is the base and the height. And what's true about the base and the height? They're perpendicular to each other. Which 2 lengths are perpendicular? Well, BC and whatever that yellow one is. Everybody see that? So now it's easy to do. You just have to understand which one is the base and which one is the height. Can somebody get that? All right, so what are we going to call the base? It really doesn't make any difference which one you call the base and the height. Give me a number. 25, okay. And what's the height? It's 10. So we multiply them together, we get 250. Do I just circle 250? Now what do I do? Inches squared. So area is always squared because you're finding squares. How many squares fit in to that? So that would be the area. Area equals 250 square inches. That's how many squares I could fit into that parallelogram, 250 of them. Everybody good? I might not be able to finish this, but at least I'll get a head start on this. Let's talk about this. Just put it down here. So watch this. Everybody watching? This is the base. This is the height. But what if I did this? What if I drew a diagonal from there to there? Now, I got 2 what? I got 1 rectangle, but I split it into 2 what? And there's 2 triangles, exactly right. So tell me something about the area of this triangle compared to the area of the whole entire rectangle. What is it? It's half, exactly right. So this triangle is half of the rectangle. So what is the area of the rectangle? What's the formula for area of a rectangle? It's the base times the height. But the triangle is how much of the rectangle? It's half. So right there, I'll put a little T for triangle. So that is the formula for the area of a triangle. Pretty easy, isn't it? Did you ever wonder why the 1/2 was there? Maybe when you were a kid, middle school, they taught you the formulas for these different areas. And they probably just told you, well, the area of a triangle is 1/2 the base times the height. So I could write it like this. 1/2 the base times the height. I like to write it like this. It's a little more compact. Okay, algebraically it just works a little bit easier. But it's the same thing, isn't it? Divide by 2, multiply by 1/2. It's the same exact thing. All right. So either one of these you could look at as the area of a triangle. But now you know where the 1/2 comes from, don't you? Because if I had a rectangle, this triangle is half of the rectangle. So the formula for the area of a triangle is 1/2 the area of the rectangle. Okay? All right. Well, that's pretty much it. There's an example, and there's a couple other ones that I could do here, but so your homework is section 7.1a, and it's 1 to 19, okay? 1 to 19. There you go. So have those done. We'll hit the triangle a little bit more tomorrow. So if you see something in the triangle, you could probably just read the lesson and understand it. It's really not that hard to do, and you should be good to go.